So last week, if you recall, we talked about pines. That's right. Southeastern pines. And so today we're going to zoom out a little bit. And I want to sort of place pines within their evolutionary context. So really, really zoom out. And the goal of this is to, because we deal with a lot of pines as arborists, to understand a little bit better about the role of pines in an ecosystem, and then the ways in which the emergence of angiosperms, flowering or broadleaf trees, has impacted the diversification and then distribution of pine trees, just to increase your appreciation for a set of trees that are widely kind of disliked, at least in this area. And we're going to come back to these three photos in a second, but I wanted to start off with one of my favorite quotes from a Pulitzer Prize winning novel that was written a couple years ago by Richard Powers called The Overstory, which is a really great book. If you haven't read it, it's well worth a read. But this is a great kind of like contextualizing why I think it's like awesome to be in a career that works with trees. So I'm going to do the thing you're not supposed to do with a presentation and read a whole big paragraph off the screen. But it's a miracle, photosynthesis, a feat of chemical engineering underpinning creation's entire cathedral. All the razzmatazz of life on Earth is a free rider on that mind-boggling magic act, the secret of life. Plants eat light and air and water, and the stored energy goes on to make and do all things. Billions of years ago, a single fluke self-copying cell learned how to turn a barren ball of poisoned gas and volcanic slag into this peopled garden, and everything you hope, fear, and love became possible. I think that's just like a really, really beautiful quote. So it's a reminder that these organisms that we are dealing with, they form the foundation of for the complexity of life on Earth. So trees are pretty cool, and it's cool that we get to work with, think about them, and then interact with them in a way that's just so much more intimate than the average person. All right, so we're going to cover this really, really quickly. 1.5 billion years ago, that's what BYA stands for, algae was photosynthesizing in fresh water. So from these freshwater algae, they moved onto land, but then these early kind of like mosses, liverworts, and hornworts 420 million years ago, these still needed water to complete their life cycle. So they're kind of partially aquatic, partially on land. Then a little bit later, 400 million years ago, plants developed xylem and phloem, which you should be familiar with from trees. These are the components of plants that create the circulatory system. And then moving on, again, we started 1.5 billion years ago, 300 million years ago. So this took a long time to make the next jump to get trees to where they are today. 300 million years ago, we started seeing cycads, or what we would call the gymnosperms. So gymnosperms preceded angiosperms, or flowering trees, by some 180 million years. And pines emerged after cycads. And so can anyone tell me what the functional definition of gymnosperm and angiosperm is? What is that denoting, Justin?
Gymnosperm is naked seed,
yeah.
Which we usually know as cones. And angiosperm is seed that is surrounded by a fleshy tissue like fruit.
Yeah, or like an ovule or an ovary. Yeah, so gymnosperm, kind of repeating what Justin said, gymnosperms are going to have naked seeds, so they're not contained within an ovule or an ovary, and angiosperms are going to, and they're going to have flowers. Some people will refer to pines as having flowers. That's kind of like a metaphoric way of describing some of their physiology. It's not literal, but I've seen pine flowers referred to, and it kind of frustrates me. So conifers emerged about 150 years ago. So really, really long period of time. And then once the angiosperms emerge, they explode. In fact, Darwin was famous for, I believe it was in a letter he wrote, talking about the damnable mystery of flowering plant explosion. And what all of these steps represent are plants becoming more efficient and more adapted to specific types of environments. And that'll become important here in a moment. So going back to this first photo, anyone have a guess what this is?
It's like ground hemlock.
It's similar, so it's a club moss. So if we go back to our evolutionary chart here, club mosses, that's a lycopod. They are the oldest lineage of xylem and phloem containing plants. So we actually see these quite commonly in our area, not this particular species. I think I took this picture in the Uaris, but something very similar, the ground cedar. So really, really ancient plant. So if you see that, you're looking at like one of the older organisms on Earth, so they're pretty cool. Then of course, this is a pine cone. Does anyone have a guess what kind of pine this is? This is one that occurs in North Carolina, but not in our area.
Is that the soft one? The slash pine?
No, it isn't, but good guess.
It's the pond pine.
Not pond pine, but like,
Ponderosa.
not ponderosa doesn't occur in North Carolina naturally. What's that?
Long missing.
I'm just gonna say it. This is a pitch pine. Yeah. To be fair, I took this picture in New Jersey, so.
Next guess.
All right. So simple in terms of its physiology. We're getting more complex now with the pine trees. And then on the right, this is an interesting one for a couple reasons. Does anyone have a guess what that is?
Southern magnolia.
Close. Right family. Or right genus.
Sweet bay.
People, yeah, sweet bay. Magnolia virginiana. So within the modern classification system for botany, this was the first angiosperm described. So we call that the type species. So it was the first Magnolia described. So it was the type species for the genus Magnolia, but then the first angiosperm that was described under modern, it doesn't mean it's the oldest angiosperm, it just means it was the first one to sort of be given the Linnaean binomial Latin treatment. So, and that is planted here occasionally as an ornamental.
A beautiful one in a
Yeah.
community in a traffic circle. I'll post on Instagram today.
Yeah, the leaves are also really pleasantly aromatic if you crush them up.
Right here.
Oh yeah, I've seen those. And then, so magnolias being one of the older angiosperm lineages, in fact, the Latin for angiosperms used to be Magnoliophyta, but then they started finding flowering plants that were older than the Magnolia lineage, so now it's, I can't remember what it is now, but at any rate, so magnolias are one of the more primitive angiosperms, and that's reflected in the relatively simple structures of their flowers. All right, so moving on to the pine family, because when you talk about pines generally, you aren't necessarily referring, or not necessarily exclusively referring to pines in the genus Pinus. And you may or may not know this, but these aren't all of the genera within the pine family, but it's all the ones I thought that any of us would recognize, including myself. So are any of these surprising to you? So all of these you could technically be correct in referring to as pines if you're speaking in like a broad sense. So yeah, pines obviously, spruce, fir, larch, hemlock, cedar, if we're talking about cedrus, not cedars in terms of juniper, that's going to be in the cypress family, Douglas fir, and then there are others. This is a sugar pine, or Pinus lambertiana in Northern California. I think it was something like 120 inches in diameter. And John Muir called them the king of conifers, or the king of pines. And you see a lot of these like in Yosemite and in the Sierra Nevadas. So, oh, wrong button. There we go.
We're all human.
So, now going back to this idea that as things progress, as they speciate, as they adapt, there is a general trend towards increasing complexity and increasing efficiency. So on the left, or your right, we're going to have another flower that is a Southern Magnolia cultivar. And then on your right, that is a milkweed. And like this is one of the most insane flowers I think I've ever seen. This is a milkweed that's native to Utah. But this is the spider antlerhorn milkweed. And then orchids tend to be the most complex flowers, and they account for something like somewhere between 40 and 60% of the species diversity within angiosperms. And they're like one of the more recent groups of flowers, evolutionarily speaking. All right, and there are important, I wanted to cover this first. So going back to one of the important ways in which pine anatomy differs from that of flowering plants. So with flowers, we've covered these terms so much, but we have like monoecious trees, we have dioecious trees, we have flowers that contain both female and male parts, and then we have flowers where the male and female parts are separated out, but there are these male and female parts. There are also male and female parts in the pine reproductive system, or in the gymnosperms kind of generally. And there's some specific language that we use to describe it. So on your left here, these are the male pollen cones. So this is where when you cut down a pine tree, when it's producing pollen, you know how there's like that huge like cloud of pollen. So that's all going to be coming from, and they all look fairly similar. Each species, some of them will be longer or different colors, but this kind of almost grub looking miniature cone, those are going to be the male pollen cones. But the key point is that they're smaller than the female cones. And then this is still fairly small. That's another pitch pine. Those get quite a bit larger, but in general, the female cones are going to be much larger. The male cones are microstrobili and the female cones are megastrobili. You don't need to remember those words, but just remember that there are male cones and female cones, and that's going to be true for cypresses as well. Like if you look on junipers, they'll sometimes have these small like yellow swellings like at the end of a branch tip with the eastern red cedar. That's going to be the male cone. When I was first learning trees, it perplexed the hell out of me. Like, what are these tiny little structures? And then later, as I got more into botany, I learned, that is the pollen-bearing structure, or the microstrobilus. All right, but none of this is a flower. So the way in which angiosperms sort of put pressure on pine trees is interesting, and it had a big impact in where we see pine trees today and what types of things that they have adapted to. And it also is going to lead us to understand a little bit better about why we might see pine trees on certain types of sites in such higher density than broadleaf trees or angiosperms. So angiosperms were really, really effective at spreading seed because they produced seeds that were like tasty. They were desirable to birds that could fly across continents. And so that opened up like a massive distributive force. Whereas pine trees, some of them will produce, have you seen in like loblolly pine, I think does this, where the seed will have a little bit of a wing, almost like a maple. And so if it catches the breeze, it can helicopter a little ways from the tree. But that's about as good as it's gonna, and I guess squirrels will eat, and birds too, but in particular, angiosperms far outcompeted pines, both in terms of regeneration and then just kind of taking over the more fertile areas. And so pines adapted in two interesting ways. They moved into abiotically stressful environments. And really quickly, can someone define biotic and abiotic for me?
Living and not living.
Yeah, living and non-living. So what would abiotically stressful indicate?
Wind.
Lack of water.
Lack of water, yeah, so environmental, essentially. So not stressful because of the presence of like decay fungi or any kind of like diseases, but the environment itself is what's putting pressure on the plants. So, and then biotic, of course, is going to mean, something living that's causing problems for the plant. So abiotically stressful environments. And then they also, interestingly, began to become really specialized to fire-disturbed environments. And there are a few different types of fire regimes, but the majority of pines are going to be fairly fire-adapted. But if you go up into the Appalachians, once you hit like a certain elevation, what is the forest type? Anyone know? So like in general, what's the general type of tree you're finding at the highest elevation in the Appalachians?
Gymnosperms.
Yeah, so fir, spruce, right? Yeah, and you're seeing all the broadleaf flowering trees a little bit lower because the conditions up there, it's a much shorter growing season. They're exposed to extremes of like cold and then oftentimes even just like wind exposure. So a lot of this is coming from one scholarly article I read, and there's a good quote that it is hypothesized that pine evolution reflects competitive exclusion from stable, productive environments by the newly emerging angiosperms. So again, the angiosperms started pushing pine trees kind of like to the margins and into environments that they just became more adept at handling. So in our area, so these abiotically stressful environments, it's typically going to mean mountains and desert, where we're seeing these extremes of temperatures and we have shorter growing seasons. So on your left here, that is a bristlecone pine in the Sierra Nevadas, Pinus longeva, one of the oldest living organisms, despite or maybe partially because of the fact it grows in super tough environments. No fire in this area. If you look, all of this is dolomitic rock, which is a specific kind of soil type, as well as, because that informs what the soil is composed of. But there's not a lot of plant material that aggregates on the ground, so there's nothing to kind of like push the fires from tree to tree. So very little fire. So bristlecone pines are not fire adapted, but they are adapted to these kinds of extreme, like this is the tree that grows at the highest elevations in the United States. And then on the right, that is the Colorado pinyon pine, or Pinus edulis, in southern Utah. You can kind of tell from the background that is, going to be more of a xeric, hot environment, where you're going to see the dominant forest types, cover types for the forests in the Southwest are going to be cypress and pines. All right. Now, to something that is very significant to both the Piedmont and then especially in the Sandhills and the coastal plain, fire-disturbed sites. So if you remember the 4 pines that we talked about as being the southern yellow pines, does anyone want to refresh my memory what the southern yellow pines are? Lollybop. Loblolly.
Crap pine.
Crap pine.
Not Jeffrey.
Not Jeffrey pine.
Longleaf.
Longleaf, shortleaf, slash, and loblolly. Of those, 3 are fire adapted and 1 is not. Anyone have a guess on which of those is not fire adapted? Shortleaf is fire adapted. Yeah. Loblolly. Yeah, because loblolly it's really specialized to taking kind of moister, marshy, lowland areas. All right, so all of these are pictures of longleaf. Longleaf has some really insane adaptations to fire. Longleaf territory burns frequently, and it doesn't burn very hot because the fires tend to move rapidly, and it burns often, at least historically. And now it's being more so through prescribed fires. And then interestingly, one of its really unique adaptations is having this kind of grass stage where it stays really, really low for like 5 to 6 years while it's developing an extensive taproot, and then it will explode and it will put on like 4 or 5 feet in a single growing season, and it's essentially trying to jump the place where the fire is burning the hottest. And part of the reason ecologists believe, and there's probably multiple reasons, but part of the reason the leaves are so long is it really protects the terminal bud that is the key part for that tree to keep alive if it's going to make it through the grass stage into adulthood. So all of these leaves provide a bit of a shelter for that terminal bud. All right. So this is just some kind of more interesting trivia, but how many vascular plants, and that is going to include gymnosperms and angiosperms, just throw out some numbers. Like how many different species of vascular plants do you think there are in the world? 10,000, much higher.
100 million.
100 million? Very, too high on 100 million. But not too far off, you're closer than 10,000. So 300, or maybe you weren't closer, 391,000. 391,000. So, and this comes to another interesting point, but of those species, of these 391,000 species of vascular plants, how many are gymnosperms? And remember, that's not going to be just pines, cycads, club mosses, ferns. So how many of those do we think are angiosperms?
300,000.
300,000.
191,000.
100, I think 300,000 is the closest. 369,000. So you can see what are the most successful type of plants on the planet today. Should be a pretty easy, yeah, angiosperms. Yeah, so they really pushed aside the gymnosperms, which had to further specialize to kind of keep their foothold. And then this is just, I think, an interesting point of comparison, but how many species of oaks do you think there are in the United States?
The entire United States?
Entire United States.
47. That's east.
147?
47.
Oh, 47, higher. Yeah.
147.
48. Probably like 250.
So did you say 90? Yeah, actually. Yeah, about 90 species of oak. And again, this is just oak. So this is one genus within kind of a large panoply of genera that are the angiosperms. So with pines, the genus Pinus, how many species of pine do you think are native to the U.S.? We may have covered this last week. 44. 44 is really close. Depending on the source, some are counting specific varieties in this number and others aren't, but it is about 40. Yeah, some sources were saying like 36, others were saying 40. So as angiosperms exploded about, how long ago was that? About 120 million years ago. And as they quickly came to dominate, and one last point that is just super fascinating. Ginkgos emerged before pines, and their range used to be, I think, pretty close to global. You can find petrified ginkgo stumps in eastern Washington. And now their range, we don't even know if there are natural stands of ginkgos because they've been cultivated for so long. But at any rate, the ginkgos are conifers and older than pines. So how does that play out with what we see today? I think one point I want to make is that pines are particularly adept at cultivating mineral soils. So soil where there isn't a lot of topsoil that tends to be more nutrient poor. And what kind of soil in the Piedmont might that be? Clay. And is the Piedmont, was it always clay, or is that more of a recent result of perhaps some other industry? I'm really leading you by the hand into this one. Yeah, there used to be a fairly fertile, widespread topsoil in this area, and it was widespread agriculture that stripped this area of a lot of its topsoil. But then also newly built, what's the word I'm looking for? Not units, subdivisions. There you go. Yeah, newly built subdivision. What are they doing to prepare those sites? Yeah. So what kind of tree do we typically associate with new subdivision? Loblolly pine. Yeah, loblolly pine. And where do we see trees that are poorly planted and look terrible that aren't pines, but like a lot of, new subdivisions. Yeah, so those pine trees, so people will talk about pine trees as being invasive, but what they really mean is that they are pioneer species. So they're going into areas with these mineral soils or that have been highly disturbed, because that's what they specialize at. They specialize at being in places that angiosperms don't want to be for whatever reason. Now, of course, there is some, that's not always true as a rule. Like there are a lot of areas where pines will mix with angiosperms, but in general, they are, gravitating towards these sites. And so when a homeowner says, my pines are stupid, they don't do anything, that's just like not true from an ecological standpoint. If you remember Catherine Bollinger's presentation where she broke down like how many lepidopterans, so the moths and butterflies, are using each kind of type of tree as a larval host, pines were much less than oaks. I think it was less than half. However, there were still something like 200 unique species of lepidopterans that were utilizing pines as a host. And so, of course, that's going to have a cascading effect on, food for birds that are eating the caterpillars. And then also, pines are evergreen And so they are providing winter cover for animals as well. So that's another important role that they play. And then they also provide a different type of shade. It's what we call dappled sunlight. And so there are different plant communities that you might find in pine-dominated forests that are getting just a little bit more light than what you're finding in a heavy hardwood or deciduous forest. And so, yeah, with some of these subdivisions, those pines may be the only trees that are going to successfully grow there for some time. Now, of course, there are other issues with that. When you have a dense stand of pines and you just carve out, a half circle, then what happens to all those newly exposed edge trees? Yeah, you're doing the right thing. Yeah, they fall over, right? Because they haven't. But that's really that's kind of a development issue. We can't really fault the pines for that, because the same is true of broadleaf trees, but we just see it really dramatically in these subdivisions where it's just like all loblolly. And so, you cut these new edges and then we start to see pine failures. But mainly the point that I want to make is that these trees deserve our respect. They're not trash trees, they're not useless. And last week we kind of talked about the way in which the southern pines are culturally really significant, but they're also a tie to our very distant evolutionary past. They're one of the things that bridge those early moments in the creation of the earth as a livable biosphere for humans. And so definitely, at least conceptually, deserve sort of our admiration and appreciation for also where they might do better and provide some large trees where you're not going to get a large oak or a large hickory or a large sweet gum or redbud or whatever people would rather have planted because the soil sucks too much. The pines don't care. They had to adapt to it in order to survive. So, anyways.
Nice.
Oh yeah, any questions?
Awesome job, by the way. In your research, is there any guess at a transitional, I don't know what word to call it, tree that came from the gymnosperm to angiosperm? Like they look at people like the missing link in evolution. Is there or the link in evolution for our species? Is there where I'm assuming where the seed was tastier? You know what I mean? Started to be more fruit or sugar or something in it?
So I'm going to answer your question the only way I know how to, which may not be the completely correct or full answer or answer directly to what you're talking about. So what cones are and what flowers are, they're iterations, more complex iterations of the same thing. They're all modified leaves. Like the bracts of a pine cone, those are modified leaves. The petals, the sepals of a flower, those are modified leaves. So it's a plant part that over time evolved to have a specialized function. And we know what evolution does over time is it takes things with a relatively simple physiology and it creates things that are more and more complex. Flowers are a similar type of structure to a cone in some ways. It's like the reproductive parts of a plant, but they are just more complex iteration of these basic leaves. And so I don't know, so we know that magnolia flowers are far less complex than orchid flowers. And so you go into the fossil record and there are, in fact, I think within the last 10 years, there was a new most primitive flower in the fossil record that was discovered. And its leaves are even its flowers are even more basic than that of magnolia. So somewhere in that line, again, but there's kind of a gap in what I've read. I don't know what it was. Yeah, and we're kind of reliant on what made an impression in mud and then stuck around, and so our fossil record isn't a complete record of what was out there. So I don't know that anyone would be able to fully answer that question. But the more simple the flower becomes as you move back into evolutionary time, I'd imagine the closer you're getting to that transition point between gymnosperms and angiosperms. And they're all part of the same kingdom, Plantae. So, any other questions or comments? Cool. Oh, does anyone know what kind of tree this is? Doug fir, nice. Yeah. You've spent some time in the West. Yeah.